All right, so on for the level 3. So this is going to be starting for, you're going to use this following data for the answers for questions 6 through 12. Please notice that I have changed these values. If you got a study guide from me, you might, on Monday or Friday, you might have different values here. Please cross that out. It will make your work a lot significantly easier. So if we go according to this data, I'm going to keep this data in front of me. We are going to answer 6 through 12. So I'm going to continue kind of keeping this data so we can reference it for number 6. So using the data above, I'm going to indicate on the diagram to the right, ranking the following substances, which one's going to evaporate first, which one's going to evaporate last. So if I'm looking at hexane, I'm going to look at hexane, I'm going to look at butanol, and I'm going to look at methanol. Between these three, which one has the largest delta T? Remembering the largest delta T is going to have the weakest intermolecular force, therefore going to evaporate first. So our hexane is going to be evaporating first. Then butanol is going to be our last one because it has our highest delta T. Excuse me, it does not have our highest. It has our highest molecular weight among the butanols, but it has our highest intermolecular forces. That has our smallest delta T. Remembering that if you have a small delta T, that is a stronger force, stronger molecule. I'm just going to write a stronger molecule. If you have a high delta T, that means you have a weaker molecule. So here we have then 20.01. Although it's close to 20.96, 20.01 is still less. So that will be the one that evaporates second. So that's something that you would then write on your number 6. So number 7, it says explain the difference in delta T values of hexane and butanol based on their intermolecular forces. So that is what we did this on when we did the post-op questions for the lab. Your main reason is you're looking at your hexane, you're looking at butanol. If you get stuck, I encourage you to draw out the butanol and the hexane so then you can see the difference between the intermolecular forces. If you have a delta T value for hexane, I'm just going to write HEX is equal to 20.96. You have a large delta T. You drew it out, you would then discover that it actually only had dispersion forces, or you could say that it has weaker forces. So then you have butanol, BUT. The delta T is equal to 3.06. You have hydrogen bonding. If you have hydrogen bonding, you have stronger forces. So you, of course, need to make sure that you have a little bit more detailed explanation on your assessment, but that is your gist of your information for number 7. So which alcohols studied? I will slide this data still over there. Which alcohols studied had the strongest molecular forces and the weakest intermolecular forces? So here you're looking at your delta T. Your strongest intermolecular forces will be the one that has butanol. Butanol has the strongest because it has a delta T equal to 3.06. And then methanol has the weakest forces, meaning that it got down to a really, really low temperature, the 4.214, and so the delta T is 20.01. That large difference is going to indicate that it has that this one is going to be weaker. This one is stronger, and you're explaining the results using using the results, which the results are that your delta T is a small number. So number 9, here we have, based on the observation from the data in the experiment, do you predict that octane will have stronger or weaker molecular forces from hexane? This is you going for the full 3. So number 9 and number 10 are for a 3. So you need to get all the way through number 10 to get a 3 on this assessment. So number 9 says, based on your observations from the data in the experiment, so we're looking at octane. Notice as you are increasing in molecular weight, so as you increase in molecular weight, here it's getting larger as we go down down our table. Here, as we go down, this is getting smaller. For hexanes and octanes and alkanes, all of those, that is still going to follow the same pattern. If you did number 4 on the post-lab questions where you plotted your graph, you will see that you have, as you decrease in, as you increase in molecular weight, you're going to decrease in your delta T. So same idea here, octane is bigger, so it's getting larger. So if you're getting larger in your molecular weight here, you're then going to get smaller. So based on that, knowing that if you have a smaller delta T, you're going to have stronger, I'm just going to write IF for intermolecular forces, stronger intermolecular forces than hexane, because I'm going to write MW for molecular weight because the molecular weight is larger. And your prediction for your T2 needs to be, so because this is the part where it's going to make it a little bit easier. Because this is such a large delta T, as long as you are making your T2 here to be somewhere that is going to be below, that is going to be above, this is going to be below, this number here is going to be above, because it's not going to have a big of a change, above 2.93. You could have anywhere from 2.94 to all the way up to, I mean, you really could exaggerate on it, anywhere up to 10 degrees Celsius. What this number is going to be a lot less important than this number right here. So this number, as long as you are following that your delta T is going to get smaller, so you could do, again, anything that is 2.95 all the way down to essentially 1 degree Celsius. So that's number 10. I encourage you to review this, ask this question during the assessment, or during our review during the assessment, and hopefully that is helpful for you. Oh, excuse me.